Okay, AP Calculus AB, Unit 5, Day 4 lesson. We're going to learn a new derivative rule today. It's a big deal. The chain rule. It's huge. Use it all the time. Anyways, before that, we have a quick warm-up. So you guys can go ahead and try this problem. The bonus is not optional. It's just bonus fun. So go ahead and pause the video and try the warm-up. Then I'll go over it, and then we'll do our lesson. Okay, find the 11th derivative. So by now you should realize, oh, well, there's going to be a pattern. So we can establish the pattern. And even if you're like, well, I've seen this before, I know what's going to happen. Okay, I make little changes in these, and sometimes it causes some other things to happen. So it might be good to just get in practice of doing this, so that when I give you something a little different, you'll be fine. Derivative sine is cosine. There's already negative. It's going to be positive sine. Third derivative is cosine. And fourth derivative is, maybe unsurprisingly, back to sine. So we got this 4. So we're going to divide 11 by 4. And there's a remainder of 3. Okay, which means the 11th derivative, which is right in the superscript in parentheses, is equal to the third derivative, which was cosine x. Okay, number 2, find the x-coordinate of all horizontal tangents. So horizontal tangents are where the slope of the graph equals 0. It's flat. So we could solve the Trig equation. -1 divided by -2 is positive 1/2. Alpha is that first angle 0, 1/2. And so it's pi over 6 quadrants 1 and 2. So x equals pi over 6 plus 2 pi k. X equals 5 pi over 6 plus 2 pi k. And then, so these are the points that we are interested in between the endpoints. So let's see. It says, so I mean that's it. Find the x-coordinates of the horizontal tangents, and then which of these locate relative minimum. So this is where we're going to do a first derivative test, which line check works really well for. And we've been doing these quite a bit for a long time. I like to test 0 for trig if possible, which is possible this time. So 0, 0, so it's going to be positive, negative, positive. And then I like to draw these little arrows to show the slopes, because these are y prime, these are slopes. So this is increasing, decreasing, increasing. This critical point is a relative max. You can tell, look, up and down, down and up. This critical point is a relative min. So there is relative minimum at x equals 5 pi over 6. Don't say the relative min is 5 pi over 6. It's at 5 pi over 6. That's the location of it. If we want to find the relative min, we plug this back in the original y equation, which maybe you might be asked to do sometimes. Okay, this derivative, this is going to be pretty gross, but maybe let's just consider changing it up. Might be good, might be bad, but cosecant is 1 over sine, and this would be x times 1 over sine. And so I think we, maybe if we multiplied by sine, that would make things a little nicer. And we would get sine x plus 1 over x. I think that's going to be much easier. We're still going to have to do quotient rule, but that's going to be a lot easier. So y prime, dy dx, same thing, low. d high minus high d low all over low squared. So x cosine x minus sine x minus 1 over x squared. So I guarantee that was a lot easier than the original one. Now, the answer you would have got from this would probably look a lot different than this. Now, we could eventually change one to match the other. It would take potentially a lot of work, but that also means that sometimes your answers in the back of the book, they're going to have it based off of one technique or another. So, all right, now for the chain rule. So, I'm going to try and set this up so it makes sense to you. And I want to just teach you a rule that you memorize that you have no idea why it works. I want it to make sense to you, which will make it easier to remember, less hard to memorize. So find derivatives of functions with functions inside of them. So we've been doing a lot of derivatives with derivatives, but how about when there's functions inside of other functions? And this is huge. This comes up on most problems when you're taking derivatives, and it's going to be a huge idea. So now, could we find the derivative of this? Right now, we would have to multiply it all out. Which means that we'd probably want to use like Pascal's triangle or something, right? I mean, so we could do it, but I mean, it would be a pain. It'd be a bit of work, right? But I want to look for a better, So you might notice that there is a function x squared plus 1 inside of another function that we could think of more simply as just x to the 10th, right? This got put inside of that. So how do we deal with that? So let me kind of lead you through an example to help us get an idea of how to attack this. And I think you guys could all probably do this problem. This isn't necessarily, this isn't a calculus problem. Derivatives of rate change, right? So here's some growth rates. Casey is growing 3 times as fast as Brian. Brian is growing 2 times as fast as Mariah. If Mariah grew 1 inch, Casey grew how many inches? Could you guys figure that out? Okay, so what do you guys think? Do you guys think you know the answer? Like, I think Casey's 3 times as Brian, Brian's 2 times as Brian, so Casey's 6 times as Mariah, right? If Mariah grew 1, then Casey grew 6 inches. So, I mean, I feel like that's something that you guys might even do in like a Algebra 1 class or something, but how can we kind of relate this to, there's definitely growing is a rate, and that's a derivative, so there's definitely something about derivatives here. In fact, we could write this like we could say dc db. So the change in Casey compared to Brian is 3, right? We could think of that as a derivative. Derivative of Casey with respect to Brian is 3. The derivative of Brian with respect to Mariah is 2. So those are like 2 little separate derivatives. We want the derivative of Casey compared to Mariah, because then that would give us our answer. But we have these other 2. But check this out. If we take, you guys somehow figured out 6, right? Well, how do you get that? That's 3 times 2. So let's think of it more, with these symbols and stuff. dc db times db dm give us 3 times 2 is 6, and that's the answer, right? So we multiplied these rates. We didn't add them, and also it kind of even makes sense, like in more simple kind of algebra, like the db's cancel and you get dc over dm. So it kind of makes sense even if you just think of those as fractions, which they kind of are. It's like a small change in c over a small change in b times a small change in b over a small change in m. So the small changes in b's would cancel each other out. So Now, what I want to do is I want to look at how we kind of relate that to this problem that we've been doing. So the way we're going to do this is we're going to use that idea, and we're going to say, okay, well, let's call the inner function u. Okay, so u is going to equal the inner function. And this is a really common letter that they like to use for this. So I'm gonna just say, you know what, the inner function is u, right? And then we're going to substitute this inside of that and rewrite it as y equals u to the 10th. Okay, so we're just kind of changing the way we're looking at, kind of saying, well, the inside is just this one letter. Okay, now the derivative of y with respect to u would be 10u to the 9th. Okay, now we weren't looking for dy du, we're looking for dy dx, but we also know that du dx, the derivative, just that part that's on the inside, is 2x. And so what we could do is we could say, okay, well, if we want dy dx, then we should do dy du times du dx, kind of like we did up here, right? And it's kind of like the du's cancel, and that would be 10u to the 9th times 2x. Okay, and that's our answer, except that it has this u in there, which we kind of made up to help us in the process. So we want all x back in our final answer. Okay, so so we could just substitute this back in for u, and it would be 10x squared plus 1 to the 9th times 2x. And then for the final answer, we clean up a little bit. The 10 and the 2x, we could say, is 20x. I would not expand the x squared plus 1 to the 9th power. That's what we were kind of trying to avoid. And this is your final answer, dy dx. Okay? So it's this idea that we're taking a rate of one thing and a rate of another thing that connects them to get the overall rate, kind of like we did up here. Now, let's see if we can kind of, that's a lot of work that we're not going to do every time. That's just trying to help you kind of understand the idea. So up here, if you want to do dy dx, it's, dy dx, it's going to be dy du first, and then du dx. Now, by the way, we call u is a dummy variable. Dummies, like crash test dummies, take the place of real people, right? Now, we don't want to actually go through and use the u all the time. Okay, next semester when we integrate, which is opposite derivatives, we can actually probably write it more often, but here we can totally get away with it. So what you need to realize is we're taking the derivative of the outside first. Okay, so let's say we have this function where there's something inside something else. So this function is inside this and this outside function is the g, the inside function is the f. And you'll notice that what we've been doing so far is we take the derivative of the outside rule first. So we put that u in there, but we took the derivative of the outside power first. So that's what we're going to do. We're going to say we're going to take the derivative of the outside function and leave the inside function the same. So derivative of the outside, leave inside the same. So, I mean, look at this example we just did down here. The first derivative we did was 10u to the 9th, where u was what was originally in there, and so it stayed the same, right? That's that. We took the derivative of the outside first, left the inside the same, and then we had to multiply by the derivative of what's inside afterwards. That's the next derivative. Okay? So this is the pattern, okay? And this is definitely not a formula to memorize. It's actually kind of we're gonna do the same problem. I'm gonna try it again, but way faster. We're not gonna do all the in-between steps of the U and all that stuff, because now we know what's gonna happen. The way we do it is we do the derivative of the outside first, the outside function first, 10 in front, decrease it by 1, leave the inside the same, and then we multiply by the derivative of the inside afterwards. And that's the chain rule, okay? And then your final answer is 20x, x squared plus 1 to the 9th power. Ooh, super fast, right? We're going to do this a ton. So this isn't, the idea hopefully becomes something that's not, it's not like this, not a complicated formula. We don't have to do all this U stuff. That was just to kind of break it up and kind of see, show you how it works. So let's try a couple on the back. Now, one of the questions you're gonna have to ask yourself is like, what is the outside function? What's the outside function? Is it like, is it the cubed? Is it the, what is it? So in this case, it's the cubed, and I would rewrite this because I find these potentially confusing and mess me up and mess my students up a lot. These mean the same thing. This is just the lazy way of writing it. Okay, that's just a lazy way of writing it, which it's always written like that, and but this is what it means. So the outside function is definitely the cubed, and then the inside function would then be the sine. But the problem is that there's an actual even more inside function on this one, and it's the 2x. So, and you got to work from the outside in. So you have multiple chain rules. Y prime equals 3 times, leave the inside the same. Okay, we're just doing the outer derivative first. Then we got to multiply by the derivative of what's inside. Derivative sine is cosine. Leave the inside of it the same, and it has its own inner function whose derivative is 2. So we got to keep going. So y prime for our final answer, probably write it 6 sine squared 2x cosine 2x. Okay. All right. You guys try the next one. So pause the video, give it a try. Okay. So what's the outside function this time? And we're not going to usually bother writing this down, but just doing it right now. It's the sine function. Okay, so y prime is cosine, leave the inside the same, and then times the derivative of what's inside, 3x squared. Final answer, we like to write 3x squared in front of trig. That's it. So, I mean, once you get the hang of it, these are kind of fast. All right, next one. Cosine is what's inside. Now, the cosine is what's on the outside. So it's going to be negative sine 3 over x times derivative of what's inside. Now, this would be a quotient rule if we left it the way it is. Low d high is 0 minus high d low all over low squared. That would go away. Final answer would be positive 3 over x squared sine 3 over x. Now let me show you an alternative way of doing this. Instead, you could reinterpret this problem as, and we've done this a bit, trying to avoid quotient rule in some places where it's easy to avoid. This is the same thing as that, isn't it? Isn't 3 over x the same as 3x and negative 1? Let's try it that way. Derivative of cosine is negative sine times derivative of what's inside. Well, that's an easy power rule. Negative 3x and negative 2. That's way easier than doing all that quotient rule stuff, right? and probably less likely to mess it up. Final answer though, I want positive exponents. So you just switch it back. 3 doesn't have a negative exponent. It stays in the top. So I think that's a good alternative. So we can maybe use that idea on this one too. Now, so a lot of times I like to rewrite these problems. I've been doing this before. In in a form that's easier to take the derivative of. This is the same as that. This is me. Now I can really focus though. It's going to be y prime equals, the outer rule is the power 1/2. Leave the inside the same. Decrease it by 1. Times derivative what's inside. Derivative sine is cosine. Leave what's inside of it the same. And the derivative what's inside of it is going to be negative x and negative 2. So there you go. That's it. Now let's rewrite it nicer. No negative exponents. So we're going to have x cosine 1 over x over 2, which should be a negative 2 square root of sine 1 over x. Oh, there's an x squared here. Actually, yeah. So the x squared should be in the bottom. There we go. Now, it's going to be easy to either forget to do chain rule, or forget to finish it, or skip a step of it. So you just got to be paying attention here. Okay. So today's assignment, we're going to do page 208, 1 to 29 odd, 43, 45, 47, 69, 71. They're all odds. Check them in the back of your book. Check them as you go. See if you're actually kind of getting the hang of it before you do the whole assignment the wrong way, right? Try and catch things you might be missing early on so that it saves you a lot of time in the end. So I'd keep a bookmark where the answers are and flip back and forth and check them as I do them. So, okay.